Lesson 12.3, Analyzing Data. Today's objectives are to find outliers, to find the standard deviation, and to find a percentile. So what's an outlier? An outlier is a value that is substantially different from the rest of the data in a set. If the data is in one variable, outliers can occur at the ends. So that means they'd be like a minimum or a maximum that are far away from the values of everything else. They can be misleading because they can affect the measures of central tendency, the mean, median, and mode. So for example, suppose a nurse is measuring the temperatures of suspected COVID-19 patients. The temperatures recorded are 106, 105, 103, 99, 98, 65, and 99. It is assumed that the 65 would be an outlier because it is substantially different from the rest of the data. Identifying outliers is important because obviously in this example, the 65 probably indicates an error in the thermometer, right? So it can show you where mistakes might have been made in your evidence gathering. All right, so here are 4 online test scores from a student taken in quarantine out of 100 points: 87, 86, 90, and 14. So identify the outlier, so 14. So we want to calculate the mean, median, and mode with the outlier, and then calculate the mean, median, and mode without the outlier to see what a difference it makes. All right, so we're going to use the calculator here. All right, so remember that you do this in the graphing. It's in Desmos graphing. So we're going to put in our list. Okay, and now I'm going to have it go into functions and stats, and I'm going to have it calculate for me the mean and the median, right? So I got a mean of 69.25 and a median of 86.5. All right, so now what if we make a new list that doesn't have the outlier? Okay, so this time I didn't include the outlier, and I'm going to calculate the mean and median here. Now this set doesn't have a mode at all because there's no repeated values. All right, so look at this now. So the median didn't change a whole lot, right? The median is the number that's physically in the middle. So eliminating outliers doesn't necessarily change the median too much, right? Because it's in the physical middle. But the mean changed a lot. See, look, it went from 69.25 up to 87.7. Okay? All right, let's talk about range and interquartile range. So a better way to know, just from you can look at data and sometimes it's pretty obvious what the outliers are, but there's a technical definition of what makes an outlier an outlier. And we figure that out is by using the interquartile range. So remember how the 5-number summaries, we had the quartiles, right? So the range is the difference between the maximum and the minimum values. So if your data, like let's say you had some data and your minimum was 15 and you had a bunch of data points and your maximum was 90, right? So the data goes from 15 to 90. 90 minus 15 would be your range. All right. So we'd have a range of 75. Interquartile difference is the difference between the third and first quartiles, right? So let's say you had your box and whisker plot that you made with your 5-number summary, right? So you have your minimum, your first quartile, your median, your third quartile, and your max. So the interquartile is third quartile minus first quartile, okay? So it's telling you how much data is inside the box in the box and whisker plot. All right, so if we want to know if something is an outlier, what we do is we find our interquartile range and multiply it by 1.5. You take that result and add it on the quarter 3 and then subtract it from the first quartile. All right, so in other words, you take your range right? And we multiply that by 1.5, okay? And that gives you some number, like let's say it was 2. So what you would do is then take this number and add 2 onto it, and take this number and subtract 2 and see how far down it goes. And then if any number is outside of those, right? So if you had a number, let's say that this was 4 and this was 7, so then 9 and 2. So if you had any numbers less than 2 or any numbers greater than 9, those would be considered outliers. Okay, so it said earlier we looked at different temperatures taken by a nurse. Here are the 7 different temperatures from before. We assumed that 65 was an outlier, so let's now calculate and see if it actually is an outlier, right? So we're going to do this with the calculator here. Okay, so I'm going to type in my data set of temperatures again. There's our 65 there. Okay, so now to calculate that interquartile range, we need the first and third quartiles. So I'm going to go under here in functions and get quartile. So I tell it use set A and find the first quartile. And then let's use set A and find the third quartile. Okay, so let's subtract those two numbers now, okay? So 105 minus 98. So I get 7. And then we have to take that number and times it by 1.5. So this is what we add on to the third quartile and subtract off the first quartile. So I'm going to take my 105, the third quartile, and add that 10.5. So 115.5, right? And now I'm going to take the lower quartile, which was 98, and subtract 10.5, 87.5. So all the values have to be between 87.5 and 115.5 in order to be considered good. So indeed, that 65 is less than 87.5, so it is in fact an outlier. Okay, standard deviation. Standard deviation is measuring the amount of variance in a set of data, right? So like a large set standard deviation means that you have a lot of variation in your numbers. A small standard deviation would mean you have a small variance. They're all kind of tightly packed together. Standard deviation is useful in determining if you should continue research depending on how much variance exists. So like if you were looking for a trend, right, then you might be looking that not a lot of variation exists. But then you collect the data and find that you actually have a lot of variation, so your hypothesis is probably wrong, right? The majority of the data should be within plus or minus 1 standard deviation. The larger the standard deviation is, the more spread out the data is. The smaller the standard deviation, the closer the data is. So for example, a teacher who finds there's a large value for the standard deviation of test scores, indicating there's a great variance, may want to adjust his teaching methods to accommodate students of various backgrounds and aptitudes, because it means that obviously there's a wide variation. There's a bunch of kids not doing so well down at the bottom, right? When test scores indicate there is little variance and when they're consistently high, then you're not so concerned, right? That means all the students are performing about the same and they're high scores. That's a good thing. All right, so what conclusions can you make? In a study done by Joseph Wu, Kathy Leung, and Gabriel Leung in Wuhan, China, the mean time from onset of death to death of patients who died of COVID-19 was 20 days, with a standard deviation of 10 days. So what that means is, right, you have a mean of 20 plus or minus 10 is 1 standard deviation, so it means the majority of people died between 10 and 30 days of getting COVID-19. In a study done by Gerardo Chowell and Hiroshi Nishiura in the Democratic Republic of Congo, the mean time from onset to death of patients who died of Ebola was 12 days, with a standard deviation of 4 days. Right, so up to 16 and down to 8, so 8 to 16 days. All right, so which virus has the greater variation in the time it takes to kill people? Right, COVID-19. All right, so how do we calculate standard deviation? It has a really terrible formula, actually. So first you have to find the mean of all your values, and then you have to find the difference between each value and the mean. So like if you had 1, 2, 3, 4, 5 kind of thing, like 1, 2, 3, 4, 5 is your data, right? And we find the mean of that. Okay, so the mean of this is 3. If you add it all up, the mean is 3. So what you have to do is find the difference between each data value and the mean, right? So that would be -2, -1, 0, 1, and 2. And then the next thing you have to do is square all of these numbers. And when you square a negative, it becomes positive. And then you have to find the average of these, right? So add them all up, 4 plus 1 plus 1 plus 4, right? And divide it by 5. Wow. Okay, so if you find the, okay, so the average of this is 2. So this is the variance. We've just calculated the variance. And now we have to take the square root of this, and that's the standard deviation. So the square root of this, square root of 2, is our standard deviation, right? Now, that is a big pain to do, especially imagine that you had a very large data set. What if you had like 20 or more numbers and you had to find the average and then find all the differences and then square each one? It's a huge pain in the butt. Luckily, your calculator can do it. Okay, so here we have a table with the number of COVID-19 cases per 1 million population by country as of 4/21/20. Find the standard deviation. Okay, so here's our list of that, and we're going to put it in the calculator. Okay, so I'll define my data set. So notice these are cases per million, so it's more like percents kind of thing, like a percent is per 100. So this is looking at things like cases as a percent or as parts per million, number per million is a lot better than looking at total cases because countries are vastly different sizes, right? So anyway, I found the standard deviation. It's there in functions. There are 2 of them, so make sure you don't use the one that says STDEVP, right? Just use the normal standard deviation. Okay, so our standard deviation is 1,647. Much easier than calculating it by hand. All right, next up, percentile. A percentile is a number from 0 to 100 that you can associate with a value x from a data set. It shows the percent of the data that are less than or equal to x. If x is at the 63rd percentile, then 63% of the data are less than or equal to x. So you get percentile scores sometimes. Like my daughter, she recently took the honors test to be in honors, right? To be in the honors program for junior high. And she scored 99th percentile on her science, but she got 75th percentile on her writing. So 99th percentile, that's the highest you can get on a percentile because it means if there were 100 people that took the test, you did better than 99 of them. You're the 100th person, right? All right, so here's a list, and it's already in order of number of masks sewed by volunteers for local hospital workers, right?